Alright, so I can't even tell you how much I don't want to do this assignment, because the first time I did it, I didn't have, my battery went out, so that's fun. Then the second time I tried to record this video, my headphones were on mute, so that was fun. So I'm going to try one more time, and after this, if it doesn't work, I swear I'm just going to stop. It's clearly the fates have decided. Okay, so taking a look at the first one here, number 11, the first thing I see is definitely the more complicated side, and then the fact that there's like tangents and cotangents in it. And so I'm going to go ahead and rewrite everything so that there's all sines and cosines, which kind of allows us to see a little bit more of how we can simplify. So tangent is actually sine over cosine, and that's going to be added to sine on top, and then cotangent is actually cosine over sine. From there, we can go ahead and distribute our cosine, and so we end up with cosine x sine x over cosine x, and that's going to be added to cosine x sine x, sine x. Doesn't really matter what order you put it in, because it's all multiplying. And so from there, we get to cancel a few things, the sines here and the cosines here. And so we end up with sine of x plus cosine squared of x, which is literally what the answer is. So that's where we're trying to go. Alright, next piece here, I see a squared, and so my strategy here is going to expand that square. So I'll start with that and see where we go. To expand something that's squared, you're technically multiplying it by itself, so I tend to do one of these little box things. So cosine of x, negative sine of x, and then cosine of x, negative sine of x. And so if I multiply them, this first piece is going to be cosine squared of x. This piece here is negative sine x cosine x. Same thing over here, negative sine x cosine x. And then positive sine squared of x. So kind of a long result here to get us cosine squared of x minus 2 sine x cosine x, and then plus sine squared of x, because there are two of these negative ones, so you make negative 2. From there, hopefully we know that our original Pythagorean identity of cosine squared plus sine squared tells us that we're going to end up with 1. So we have a 1 instead of sine and cosine, and so it's going to be 1 minus 2 sine of x and cosine of x, which is what we were looking for our solution. Again, it probably doesn't feel like a solution, but that was supposed to be our ending point. Alright, next piece. So cosine squared of x minus 1 is our numerator, and then cosine on the denominator. So definitely going to change this more, if you will, complicated side. Our Pythagorean identity, especially if you rearrange it a little bit, allows us to change this first piece, because cosine squared minus 1, if you rearrange it, actually equals negative sine squared of x. So our numerator gets to be negative sine squared of x over the cosine that was there. If we take the time to expand it, we end up with a negative, a sine over cosine, which of course is tangent, and then a sine. And so our answer is negative tangent of x, sine of x. Alright. The next one is not necessarily super fun, but we're getting a common denominator. Pretty much any time that I see 1 plus cosine or 1 plus sine without a squared, because squared would probably mean that there's some sort of Pythagorean identity, I know that I should probably just multiply by a conjugate. So the conjugate, or kind of that opposite, is a 1 minus cosine, because this side has 1 plus cosine. And that's going to be over 1 minus cosine again. Over here, we have 1 plus cosine as the conjugate, so 1 plus cosine, there it is. And so if we think about the denominator and expanding that a little bit so that we know what it would multiply to be, 1 minus cosine of x and 1 plus cosine of x is going to be 1 negative cosine x, positive cosine x, which is the whole point to cancel, and then a negative cosine squared of x. So ultimately in our denominator we get 1 minus cosine squared of x. So the numerator on the left is going to be 1 plus cosine x over our new denominator. And then the right side is going to be 1 minus cosine x in the numerator, and then that same denominator. And so because of that, we can write it as all one fraction, because they have the same denominator. So the numerator is this kind of long phrase of 1 plus cosine x plus 1 minus cosine x, all over 1 minus cosine squared x. And maybe you're asking, why couldn't we just cancel one of these over here? Because any time that you, I mean, this is not 1 minus cosine the quantity squared, it's that the cosine is only squared. So you would need kind of two sets of this 1 minus to be able to cancel, and plus it's minus and plus, and anyway, this one doesn't cancel either. So got do a little bit more fancy math than that. So this guy here, for instance, positive cosine and negative cosine cancel. If we bring our 1 and our 1 together, that's going to make 2. And then actually by a Pythagorean identity, this actually equals sine squared of x. So we've got a sine squared of x. And then we look at our answer, we're trying to get 2, which we have, but then cosecant. And so that actually just comes from bringing our sine up. So 2 and then cosecant squared instead of 1 over sine. So, all right, moving on. Next one is kind of fun, and I would know because I've done it like 4 times. So here we go. It's just 2 Pythagorean identities. So definitely looking at the left side because it's the more complicated side. But actually, once you apply the fact that this Pythagorean identity is actually just secant squared of x, and then this Pythagorean identity is actually just 1, we now have secant, not sine, squared of x over 1, which of course is just secant squared of x, and so that's our answer. Sweet. This next one has a few more steps than this one, so it's nice that we have some extra space here. So I'm going to start actually with this one over here, only because I see that it's 1 minus, and so when it's 1 minus a singular cosine or sine, I tend to multiply by its conjugate to find out what's happening. Are there other ways to solve these? Why, yes. There are like infinite ways of solving these. It's just that you may or may not be doing like certain redundant properties or something like that. So either way, our denominator here is 1 minus cosine, but then that's times 1 plus cosine. And so because we're multiplying by our conjugate, remember that our middle terms end up actually canceling. So that's nice. And then negative cosine squared of x is happening. So from this we get 1 minus cosine squared of x. Alright, so that's our denominator, but then our numerator is actually distributing that sign. So if we distribute that sign, we get sine of x plus sine of x cosine of x, and then our denominator of 1 minus cosine squared of x. Through a Pythagorean identity, this guy is going to be sine squared. And so we end up with sine of x plus sine of x, cosine of x, all over sine squared. Then we get to cancel some of these pieces, and maybe without too much splitting up. Nope, I am going to split it up. no, I won't. This sign and this sign, there's both of these factors have one of them, and then there's a 2 down here, so we make it a 1. We'll cancel. And so we actually end up with 1 plus cosine of x over sine of x. So again, if you needed a step in between there, you could have noted that it's sine of x over sine squared of x plus sine x cosine x, and then canceled one of the signs from the top and bottom. So either way, this is where you get to go back to understanding what you're trying to get to, because right now I have a 1 plus a cosine, and I actually want secant plus 1. So to turn this 1 into a secant, I could divide it by cosine. To change this 1 from a cosine, I could divide it by cosine. And to change this sine into a tangent, I could also divide by cosine. So oddly enough, within the problem, I am going to divide each of these pieces by cosine. Because I would have been able to factor that out before, so now I'm just kind of refactoring it back in. So I'm going to get 1 over cosine of x plus cosine of x over cosine of x, and all of that over sine over cosine of x. And so hopefully you can see that that becomes secant of x plus 1 on top and tangent of x on bottom. Alright. So next one, number 29, kind of a lot going on as well, but we're going to write it first as sine and cosine. So again, I can kind of see that there's cotangents, and anytime there's cotangent or tangent, it's helpful to write it as, or in any other inverse, reciprocal trig. So secant and cosecant and things like that. Anytime you have one of those, it's best if you translate it into just sines and cosines so you can kind of evaluate. So taking a look at this left side here, cotangent is actually cosine squared over sine squared. And then that cosine squared is going to just stay cosine squared. And now I'm trying to get these to subtract, so I need a common denominator. So this one's missing a sine squared in its denominator, so we'll just multiply that in. And so now we have cosine squared of x over sine squared of x minus cosine squared x sine squared x over sine squared x. Alright, so then we are going to go ahead and combine them, and so we have a cosine squared of x minus cosine squared x sine squared x over sine squared x. Again, you got to resist the idea or hope that these would cancel, because of course now there's an addition or subtraction in between them, but anyway, we put that in there so we don't want to take it out. So what we do want to take out, however, is the fact that this term has a cosine squared and this term has a cosine squared. So if we take that cosine squared out front, we are left with a 1 from dividing it out here, minus sine squared of x over sine squared of x. And so hopefully if we're looking at our answer here, and we're trying to get cotangent, right? And so cosine over sine is cotangent, and so that's kind of where that's coming from. So this piece is cotangent. And then this, cotangent squared, and then this one from a Pythagorean identity is actually equal to what 1 minus sine is cosine squared. And so we have a cosine squared, we have a cotangent squared, and of course in the answer they have cosine squared first. That's fine, and then cotangent, because multiplying can be in a different order if it needs to be. Alright. So number 32 is a little less intense than the rest of them. That's nice. I see this left side and I see a lot of tangents going on. So I'm going to actually just divide both pieces on the left by tangent squared. So I'll take that out front. And I have a tangent squared x and a leftover of tangent squared plus 1. And then, of course, anytime you see a squared and a 1, you're probably thinking a Pythagorean identity. And so our Pythagorean identity is the fact that that is actually secant squared t. Oh, these are t's, not x's, so hopefully I've been doing that up until now. That's weird to have tangent with a t. Okay. Anyway, and so then by the Pythagorean identity, our tangent squared, so this is kind of weird, but anyway, our Pythagorean identity, tangent squared, can become secant squared minus 1. And so we've just changed the first piece into secant squared t minus 1 times secant squared of t. And so to get back, we would distribute that and get secant to the 4th of t minus secant squared of t. So that is how we changed everything from tangents of pretty much the same phrase to secants of almost the same phrase. They're not, of course, exactly the same because there's a subtraction going on. All right, and then our last two, thank heavens, is going to be multiplying by a conjugate. So hopefully you can see here in the denominator you have secant x minus 1. So I'm going to multiply this side by secant, this is going to be sloppy. Alright, secant of x plus 1 and secant of x plus 1, so that we can get our common denominator here. So secant of x plus 1 and secant of x minus 1 leaves us with secant squared of x, a secant of x, a negative secant of x, which will cancel, and a negative 1. So our denominator is going to become secant squared of x minus 1. So that denominator is secant squared of x minus 1, and the numerator is going to be secant x plus 1, the quantity, times what was initially in the numerator, which is tangent of x. And all of that is over secant squared of x minus 1. Secant squared of x minus 1, of course, with the squared, is going to be a Pythagorean identity. And so it's actually going to equal tangent squared of x. And so if we have secant squared of x minus 1 times tangent of x over tangent squared of x, we now can reduce this tangent with one of these tangents and be left with secant, oh, I wrote squared in this accidentally, secant of x minus 1 over tangent, which is what we wanted. So basically tons of algebra. Okay. And then the last one, hey, we're probably going to need to keep our answer in mind. We're actually going to do this one kind of like we did with, where is it? This one. Alright. Because hopefully if you take a look at what we're given, we need secants, and we have 1s, and we have cosines, and we need to make them 1s. But otherwise, it is still a plus on top and a minus on bottom. So pretty much they're the same, only I would basically just need to take each of the left side and divide by cosine, or take each of the right side and multiply by cosine. So I'm going to divide all by cosine of x, and so I end up with 1 over cosine of x plus cosine of x over cosine of x over 1 over cosine of x minus cosine of x over cosine of x. And so if we put all those together, 1 over cosine becomes secant, cosine over cosine becomes 1, 1 over cosine is secant, and then subtracting cosine over cosine, which is 1. Alright. So again, lots of algebra going on, but at the same time, a lot of Pythagorean identities to kind of switch things up, and then a lot of conjugates and getting common denominators. So that, finally, is our 5-2 assignment. So hopefully that makes more sense.